In this lesson, we're going to learn about how to prepare and dilute solutions. So in the preparation of a solution, you want to be as precise as possible. So we use some specialized equipment. First of all, you would need to figure out how much mass of the solute you need, and you'll measure that in a balance, whether it be a triple beam balance or an electronic scale. The more precise the scale, the better. Then you're going to dissolve the solute in a small volume of distilled water. So you'll pour it into a beaker, mix it with a stirring rod until all the solute has dissolved. Then you're going to transfer your solute solution into a volumetric flask. So a volumetric flask has been calibrated in such a way that when you fill it to the marking, it will be exactly or pretty close to exactly that volume. So you'll use a funnel to do that so you don't miss pour. And then you will rinse your beaker, your stirring rod, and your funnel with distilled water to make sure that you haven't left any of the solute in the container. And then you'll carefully make up to the mark with distilled water. You'll stopper it, and then you'll invert repeatedly to mix your solution thoroughly. We'll go through the steps now to make 100 milliliters of a 1 mole per liter solution of sodium chloride. So first of all, you need to know how many moles of sodium chloride. So if you remember our little triple peaks, I'll just put it up here. So remember, mass over the molar mass makes the moles. We won't need this side of the triangle, and then C times V is the number of moles. So first thing we need to do is find out the moles. So that's equal to the concentration, so 1.0 moles per liter, multiplied by the volume, but our volume is in milliliters, so remember we'll need to move our decimal place over 3 or divide by 1,000. So it's going to be 0.100 liters. So our liters are going to cancel out. So we're going to note we need 0.10 moles. The next thing we need to do is figure out what mass of solute we need to add. So that's equal to the moles times the molar mass. So we'll need to find the molar mass now. So it's the molar mass of sodium chloride. So the molar mass of sodium is 22.99 grams per mole plus 35.45 grams per mole. That's equal to 58.44 grams per mole. Now finally we can find out how much mass we need. So mass is equal to the number of moles times the molar mass. So that's equal to 0.10 moles times 58.44 grams per mole. And that is equal to 5.8 grams of sodium chloride. So if we wanted to find out how to make this solution, we would first have to find out the mass, and then we'll have to follow those steps from before. So we'll weigh out the 5.8 grams of sodium chloride. We'll put some water into our volumetric flask with distilled water. But in a separate beaker, we'll add the solute and a little bit of water to dissolve the solute. We'll swirl that in the beaker and then pour that into the flask through a funnel. We'll keep rinsing until we don't have any more. We're sure that the solute's all been rinsed out, and then we'll continue to fill the volumetric flask with water until the bottom of the meniscus touches the graduation line, and then you'll put a stopper on and mix, invert to mix. So if we need to dilute a solution, we have to ask ourselves the question, if the volume of a solution is doubled, what happens to the concentration of the solution? And the answer is that it is halved if you don't change the amount of solute in that solution. So the concentration of a solution is directly proportional to the volume. So we can use this relationship, C1 times V1 equals C2 times V2, and then we can solve for our missing value. So in the example we're going to work through, the question says, I need to make a 2-liter solution of 0.10 moles per liter sulfuric acid. What volume of 18 moles per liter sulfuric acid do I need to add? So when we order our sulfuric acid from the chemical supply company, it comes in this concentration. So with quite large concentration, we don't work with that highly concentrated sulfuric acid. We always dilute it into a much smaller form, so 0.1 moles per liter. So this is going to be our C2. That's what we want to end up with. This is going to be our V2. This is the volume that we want. This is our initial concentration. So if we rewrite our equation here, so C1V1 equals C2V2, we want to know what our C1 is, so we're going to divide each side by V1. So these will cancel out. So this means that our C1 is equal to C2, which is 0.10 moles per liter, times V2, 2.0 liters, divided by 18 moles per liter. And that is going to be equal to 0.011 liters. If we want to convert that to milliliters, we can multiply that by 1,000 or move the decimal place over 3. So 11 milliliters if we report in the correct sig figs. So 11 milliliters is what you'll need to add of the solution, and then fill up to 2 liters to make your solution of 0.1 mole per liter sulfuric acid. Now, sometimes we will be asked to make serial dilutions or talk about serial dilutions, and that's when you make a series of dilutions, usually of the same factor. So if you take a look at that, it will cause an exponential decrease in concentration. So if we started off with 9 milliliters of stock solution, and we take 1 milliliter out and put 9 milliliters of saline or water, that's your first dilution, and then you do the same thing. You take 1 milliliter out and then add 9 milliliters of the solution, the solvent, over and over again until you get your last, and that will cause a consistent exponential decrease in concentration.